All right, welcome everybody. Good afternoon. We're going to be having a little panel on exploring beyond the layer 2, specifically layer 3s and app chains. We've got a fantastic lineup for us all. Some really interesting projects here. We'll start off with introductions. I'm Teddy. I work at Starknet Foundation. So let's go.
I barely hear you.
You can barely hear me?
Yeah.
Let's get closer. All right. Let's start off with introductions. We'll go down the line, tell us who you are, what are you building, and we'll start from there.
Sorry, I need to hear again.
Who are you? What are you building?
Okay.
Start off with introduction.
Yes, so I'm Clément. I am actually building Cairo, which is initially an EVM implementation in Cairo. So Cairo, the language developed by Starkware. And we are about to launch the testnet soon. My net might be an L3 or an L2 or directly in Starknet, yet we need to figure out. So, yeah. I'm going to get the...
Hey guys, I'm Luke. Our parent company, MQ Lab, what we do is we build key technologies to help other people build high-performance chains. Mostly we focus around consensus layers and execution layers. And we also have current partnerships around more unusual things like BTC L2's that we deploy with other partners.
Awesome.
Hi, my name is Anurag. I'm co-founder of Avail. Previously, I co-founded Polygon. On Avail, we work on a few technologies we dub as the Avail Trinity. One of them is the state-of-the-art data availability solution that is built on KZG polynomial commitments and validity proofs. And we also announced a couple of products last week in Denver, Avail Nexus and Avail Fusion, primarily coordinating products that coordinate the roll-up centric future. And we work very closely with Starkware, especially on the Madara integration piece, and hope to work with them in enabling the L3 Starkware ecosystem in general.
And hi, I'm Casper. I'm the co-founder of Herodotus. At Herodotus, we're building storage-proof technology for Ethereum ecosystem blockchains. This allows us to unlock historical and cross-chain data access. And yeah.
Awesome. Welcome, guys. Thank you for being here. So I wanted to start off at a high level in terms of what layer 3s or app chains are. For those who might not know, I really think layer 3s in particular come down to the first aspect of what blockchains really provide, and that's block space. And app chains come about by thinking that, yes, we need a way to scale underlying chains, layer 1s and layer 2s. And this idea that a common block space between all applications isn't that great for everybody. A wallet, a roll-up, a DEX, a lending solution, a game need not compete with each other for the same block space. In essence, it's not productive to do that. It's not scalable, and we could begin to get these system complexities manifesting user experience, network congestion, high fees, things like that. So my understanding of layer 3s and app chains in general really start there. It starts off with saying, hey, is there a better way, is there a better product, a better block space that we can use and build to offer to our users, to give a better user experience, to have more scalable solutions in this case. I would love to hear sort of what your ideas of what is a layer 3 in a distilled version for our members of the audience and those watching. What does it do? What's it for? How does it come about? So who would like to start?
Yeah, so I'm personally not sure that the app chain, because sometimes the L3s are think about like every application can have its own blockchain, so they don't compete for the block space with others, and they all commit to the L2. So I think if we agree that this is an app chain, I'm not sure that app chains really have a strong future, because as a developer for one single application, you may not really want to run your own blockchain. That being said, I think that being able to build on top of other chain to inherit the security without but still reducing the cost of the data at the end of the day is something interesting. It's something interesting when you need to run a blockchain. Like I know, for example, that the Pragma Oracle, they are meant to run a blockchain because they want to have a consensus of the data, and they are also operating on Starknet. I think that for them it makes lots of sense to run a free. For Kakarot, for example, if we want to operate a real blockchain, I mean the user expects a blockchain and there is need for a consensus, then we can run on top of Starknet if it makes sense, and it's an L3. Yeah, so I think that I think that the L3's offers more flexibility in terms of, I would say, pricing and without so much compromising on the security of the data. And I think that with storage-proof bridges can be quite fast, even if it's L3, even if it's L4, whatever you can imagine. So this is, yeah, this can bring value to the user. I would not say so much for the app chain themselves. I don't know what guys you think about this.
Yeah, I think Clement just mentioned a very good challenge to the concept too. We're generally pretty bullish because we think, we call it L3's, but I think at that point it's not about stacking another layer on top of an L2. There's less value in that, but more value in terms of vertical specialization. Like different applications kind of, they want slightly different trade-offs in terms of the infra design. Like out of, let's say, 4 to 5 dimensions, you could have, say, 3 dimensions that are very, very optimized. But those 2 others would have to be, slightly concessed. Right? You need to make concessions on top of those. And so for different applications, those choices would be quite different. So that's where I think, in the future, applications will have a high demand for application chains. And also, in terms of block space and whatnot, there's also things like properties like, say, privacy, right? Some applications might want high privacy. Others have, less of a need for privacy. So if you need high privacy, sometimes having an application chain of your own, that's a different domain and could be beneficial.
So maybe if I may ask a question, like you think that possibly domain-specific chain, like an L3 for gaming might have special needs, an L3 for privacy might have special needs, an L3 for, but it's domain-specific and not application-specific. Like you will be joining the blockchain of your domain and benefit for the setting optimized for this kind of usage.
So I think for similar applications of a single domain, you would have similar design choices. That's true. But then also, let's say for things like social and gaming, it might actually make sense to separate the chains once you have enough users, right? Because let's say you have 100 million users on one game, and then on another too. I think that at that point it might be a good idea to separate. But yeah, love to hear what everybody else thinks.
Yeah. So I generally think of this as so first let's what are L2s for, and then you come to L3s, right? So essentially L2s are primarily started with when rollups started coming onto the scene, and you could bring computation off chain from, let's say, a base layer like Ethereum, for example. And so L2s are primarily these off chain verifiable compute mechanisms in general. And L3s are the simplistic version is that these are off-chain computation mechanisms on top of this L2s. But really how I like to think of this is if I were to put an analogy of, let's say, how apps on the internet work, right? Apps on the internet are not all deployed on one single supercomputer, right? There are a lot of microservices and some microservices are very fat, some are very thin, for example, and then whenever required, they interact with each other. And because of the evolution of ZK and validity proofs specifically, what has enabled us to do is create these pockets of execution. These could be L2s, that could be strapped onto L3s, for example, but ultimately these are off-chain verifiable compute mechanisms, and you pass validity proofs from one L3 or app specific rollup or general specific rollup to each other. Now there are nuances in how all of these are structured. If you're doing a rollup on Ethereum, you have a certain cost and efficiency trade-off, for example, security trade-off. If you do an L3, you still need to think about what other trade-offs to keep, for example. So it's but because all of this is all very, at least in a Starkware-centric future or validity-proof-driven future, the execution is guaranteed by these mathematical proofs. You are able to kind of do away with the safety guarantees. There is a liveness guarantee construction in all this, but essentially how I view L3s is some sort of off-chain execution. Now, whether you define something as an L2 and L3 depends on what it is bridging to, for example. So there's a lot of nuance, but just to set the context.
So in my eyes, the way I visualize layer 3s and app chains is about giving application developers ownership over the stack that they're working with. So like all the previous panelists have mentioned, depending on what you're building, you're going to have different requirements, different needs. And similarly, like we oftentimes look at Ethereum as a decentralized computer, and we can actually compare this to like traditional computer systems. When you're trying to get a VPS or EC2 instance on AWS, there is no one size fits all. You can get a generalizable one. However, at the end of the day, you are sharing those resources with others, unless it's a dedicated instance. And with application-specific chains and L3s in particular, the way I view it, it will allow developers to tailor their stack to their specific needs. Obviously, a game will have different needs than someone building an on-chain perpetuals exchange. But yeah, that's how I see it.
Yeah, fantastic. I think it's incredibly important for app chains in general to focus on what end users need. Not everybody wants to be familiar with Ethereum stack, for example. We won't onboard billions of users as everybody has to succumb to understanding one specific stack. It doesn't map to their mental model specifically. And this is what you're saying in terms of domain-specific chains or app chains, right? It's really important that it's tailor-made to what end users need. You're all building incredibly interesting things. I wonder if you could all talk about specifically what you're building, how it's relevant to Starknet, and how it's relevant to layer 3s and scaling solutions. Casper, do you want to start?
Sure. So at Herodotus, we are building storage-proof technology. Essentially what that means is that we're able to cryptographically verify that data exists on a given chain, on a domain, and verify it against something like a block hash or a commitment, such as like the root of a Merkle Mountain Range data structure. And what this allows us to do, it allows us to read, first off, data that's located in other domains or historical data, which was not possible before. And our approach, like our primary product, is something we call Turbo. And Turbo essentially allows you to make these, allows developers to make these storage-proof queries in one line of code. And yeah.
Awesome.
Yeah, we build infrastructure that primarily looks at solving problems of the roll-up-centric future. So essentially, first product that we work on is called AvailDA, which is primarily for roll-up scalability with scalable data availability. And then once we kind of go into this, enable a lot of roll-ups at scale, and today we already have like 50 or 100 roll-ups running in the wild. Tomorrow, like that's going to be, probably thousands of roll-ups. And so we also work on something called Avail Nexus that we recently announced. That sort of works on things like proof aggregation and data availability sampling to enable roll-up interoperability. Essentially, like once we move into this world of 1,000 roll-ups, there has to be some coordination infra to ensure that users are not subject to this complexity at like this multi-chain infra. So that is a rough summary of what we work on.
Yeah, so for us, for app chains, I guess our kind of focus on contributions, maybe in one word, is just performance. We focus a lot on, say, parallelism for VMs so that they become faster. Also, like single nodes, how do we run these single node sequencers faster? And also, for the consensus in general, how do we have higher throughput? So basically focusing on how to help people make app chains that are faster, more high performance, because I guess generally the consensus people have been talking about right now is that it's kind of hard to run your own infrastructure with app chains, right? So kind of once people want to run these in more and more shared fashions, you will definitely have bottlenecks in terms of, okay, it's shared. That shared nexus really needs very, very high performance compared to just each of the branches. So that's kind of something that we are preparing for Web3. Yeah.
And at Kakarot, so we are building an EVM say a ZK EVM, then because it's the word anyway. So an EVM with the Starkware, Starknet stack. The end goal is that so the user developers or user can use the EVM. So this is the regular EVM, but benefit from from the tremendous innovation that Starkware and Starknet are bringing to the system. So yeah, for us, it's just like there is the Starkware and Starknet. I'm a strong believer in Starkware and Starknet. It's really good network, but for some reason, sometimes you still want to use the EVM. I don't think the EVM will die. And so we bring this, I would say not interoperability, but it's a compatibility layer so that the people can enjoy both the technology of Starkware, Starknet, and the EVM.
Fantastic.
If I can just add one more thing that I missed off. So one other thing that we've recently announced in collaboration with Starkware is the Cairo verifier. At Herodotus, we built the Cairo verifier, which allows you to it essentially paves the way to the deployment of layer 3s on top of Starknet. And yeah, that's going to be pretty exciting in the future.
What do you think, Casper, about the new verification layer that have been announced, like the aligned layer, for example?
So there's obviously different types of new assumptions, and that's also collaborating with EigenLayer. There's different trade-offs. I think it's exciting to see this kind of innovation happening. It's to be seen.
Fantastic. I think on one hand, app chains, obviously, we're thinking about the end user experience. We're thinking about something very specific in a specific domain. But it's not just about the end application, it's about the stack as well. The stack is perhaps just as important as the end application because of what it enables. And one hot topic of late is modularity. We are in some form of a modular era. Whether app chain developers want to create that bespoke execution environment, whether it's for EVM-like solutions or whether it's for something else, I think that the stack presents many opportunities to iterate across the solution and idea space, whether that you want a different consensus mechanism or a different sequencing algorithm, whether it's first come, first serve, bull shark and narwhal, hot stuff, things like that, or your custom execution environment, or other things too, like if you want to think about privacy and encrypted mempools. I wonder how each of you see sort of modularity enabling richer ecosystems of app chains, or perhaps allowing developers to discover new and interesting use cases for app chains. I wonder what you think. Pascal, do you want to start?
Sure. So for modularity, currently at Herodotus, we are exploring integrating storage proofs into various different types of DA systems, such as Avail DA and Celestia. With regard to like modularity, we think like with L2's and L3's in general, like fragmentation is here to stay. It will continue happening. I think the incentives of launching new chains is very high, and instead of fighting against it, it's better just to accept that that's a new reality. Ethereum in the beginning started to scale horizontally via like layer 2s, and right now we see that happening with L3's. L3's are scaling L2s. So our approach is that we want storage proofs to enable this cross-chain data access to ensure that the applications that do rely on this data that is located in other domains is being accessed in a secure manner that is secured by cryptography and not like signatures.
Yeah. So modularity is an evolution in terms of blockchain architecture, right? Like most systems, when they evolve, right, like they usually start off very monolithic. Like I think I just gave this example at a panel some time back. Or I think it was Sriram. I don't remember, but essentially, like initially, if you take the analogy of a motorcycle, for example, right, like it's first built very monolithically, and when blockchain infrastructure evolves, right, like you specialize, right? Like I mean, the wheels are made by someone, the engine is made by someone, like the brakes are made by someone else. And so you specialize, and that's why you modularize, because you want to ensure that the path to making any system is much more efficient, much more better, and just modularizing it essentially makes it easy to build and test one system, and which can then interface with other systems to make a whole, right? Like so, like in the first cars were like maybe built like in one go, but right now everything is built very modularly, and the same is happening with blockchain architecture as well, that there are different layers specializing, and right now it looks a little bit disjointed because you have to take one piece, fit it into this, for example, but just give it a few months and like it'll all start to work beautifully well, and it's good in general. And to that point about correlating it to the app chains, like specifically when we mention app chains, I specifically refer to those as app-specific rollups, not like chains in themselves. It's just a better way to kind of delineate. And app-specific rollups I'm pretty bullish upon because of the modular thing, in the sense that today we see a lot of very opinionated rollup stacks with, like, let's say ZK EVMs or optimistic EVMs, and these are actually combinations of two things. There is the execution environment, but there's also a state structure attached to it. App-specific rollup stacks will, like in the future, specialize with, let's say, taking the Cairo execution environment or even the Kakarot execution environment, and then attach it to a very opinionated state structure or a data structure where provability is more efficient or more fast, for example, and so on, depending upon the proving systems. And we are already seeing all these experiments with, like projects like Sovereign Labs and Stacker Labs and so on. But yeah, that's kind of the gist.
Yeah, so in terms of modularity, I guess it's kind of two levels, at the network level and at the node level. For us, what we build, we generally like to, I guess the node level is slightly greater in terms of granularity, right? It's node level. So in terms of what we develop for application chain stacks, we like to have it at the node level first, if possible. So parallel VMs, or it's actually what we built for Madaro wasn't the EVM itself, but or the VM itself, but something to help the VM. So those things are modular at the node level. Also consensus stacks. The consensus network has to form a network, but that can be plugged into every node at the node level. So that's kind of how we see, is a good way to preserve composability and interoperability within the industry. Kind of building for these very composable nodes. There's also a lot of great companies out there building for high performance nodes today too. I think that's a great trend. And also at the network level, I think lots of trends that we see. These stories were pretty much there from day one in crypto, right? Like Polkadot had the parachain vision. There's like subnets and whatnot. They never really took off because they're slightly too opinionated and they kind of fragment the ecosystem. But I think with kind of L3's coming up, kind of modularity, which DA stacks are doing a lot and contributing a lot to. I think we're having a clear vision across the industry of what subsets of the network should be kind of a certain layer. So I think that's like a great trend, and kind of for us, the philosophy is to build for the modular node if possible, and then also at the protocol level, how to help developers support these key protocols, and yeah.
So I think that's interesting that you mentioned that back in the days, like already in the Polkadot philosophy, the Avalanche philosophy, I mean, it's been thought about like subnets, parachains, sidechains, like chains that should work all together. And I think that at the end, for Ethereum, and as far as understood, we have started to talk about like L2 because it was built on top of, because the goal was really like to scale something. And so the idea was to inherit the full pack, the full Ethereum. So we wanted to post the data in Ethereum, to verify in Ethereum, to sync with Ethereum. So it's like we were not really using all these. I don't know. What I wanted to say is that, so right now when you talk about L2 or L something, like you completely 100% rely on the underlying layer. That's the goal of the message. I'm L2s of Ethereum because I do everything on Ethereum. But it's somehow like when you buy a suit, you need to always use the jacket with the trousers, with the shirt that you have had. Like you cannot mix and match. But at some point we realize that maybe still mix and match is interesting. And I think that we will see with the usage and the demand of the users. To me, I have to say that it's not completely clear if the modularity will really bring, what kind of value it will bring to the end user. I think it's interesting to be able to do it, and I don't really know how it will eventually be used, to be honest.
Yeah, it's fantastic.
Yeah, just to counter one point there is, the moment you build a roll-up on Ethereum, like it is inherently modular, right? Basically Ethereum it handles part of the responsibility, let's say data availability and settlement, and the roll-up does the execution bit, right? So inherently that construction itself is modular. So if you expect all the computation to be done on Ethereum, for example, right? So that's that limits to the computation that you can do. Like the moment you take execution out, that is an example of modularity. So in essence, what we see from a L2 angle itself is an example of a modular use case in that sense, right? Like, I mean, essentially modularity is when the first roll-ups came or when the first plasma solution came. Like, I started my journey in crypto in 2017 when we started building a plasma solution. And that was an example of a modular solution because you used to take execution and data availability off-chain. That didn't work out, but rollups came into the picture. And then we just moved execution off-chain, right? Like, and Starkware is an example of, like doing exactly that, right? Like, so modular, there is, I mean, of course, you can take this to the extreme, like L can be Ln, for example. But the reality is that the moment you take execution off-chain, it pretty much becomes modular in that sense.
I think perhaps one interesting thing about modularity, to move on to the sort of the last topic-ish, is that modularity gives developers flexibility. It allows them not only to build the stack that they desire for their end users and bring them that value, but it also perhaps gives them the opportunity to pick up that stack and move it elsewhere. And there was a really good blog post a couple of years ago that was talking about layer 2s on specific layer 1s, and I think it applies for layer 3s as well, in that the app chain or the layer 2 that sits on a layer 1 or a layer 3 that sits on a layer 2 isn't very dependent on the layer it sits on. The layer below it is highly dependent on the app chain in this example to bring a lot of value to it. But I think that's sort of naive in a sense that if app chains are composable, if they're compatible with each other, better product can be built with them. I wonder if interoperability, app chain communication, layer 3 communication is something important that you see as not only possible, but important to create a rich and thriving ecosystem of layer 3s on, for example, Starknet, to bring out that sort of rich vision, a collaborative ecosystem where better product can be built. I know you might be doing something in that regard.
Sure. So when I think layer 2s oftentimes by the community, wider community, got a reputation of being responsible for the fragmentation of the ecosystem. And I think that comes to, like, that's the case because of the definition of bridging. Essentially bridging, like moving the asset as well as its associated economic value to a specific domain is what widely people would represent as bridging. But with something like storage proofs, for example, I think a key innovation that they bring forward is the fact that you separate an asset's like utility as well as its economic value. And a good example of this is, for example, an integration that we've built alongside Snapshot, where on a layer 2 on Starknet, we're able to vote based on assets that are located on L1. We never had to bridge them by the formal definition. We simply generate a storage proof that showcases, hey, you are the rightful owner of that asset on L1. And that's a very powerful thing to kind of apply with what was previously mentioned about offloading compute and execution onto these different layers. And I think this technology will be very complementary to layer 3s and app chains that don't necessarily need to take, again, that liquidity towards there. They can simply perform functions based on its representation.
So how I would like to view this is, so like we start with this very monolithic sort of blockchain, right? Like let's say Ethereum, and it has like tremendous security, but high fees in terms of user transaction fees. And then you basically build this L2 architecture on top, which kind of offloads execution to a different layer and increases the throughput, but also increases the interaction points for the user, right? Like, so suddenly the user doesn't have to interact with only the Ethereum chain, but they have like the Starknet chain, an Optimism chain, an Arbitrum chain, and so on, right? Like, and if you like contrast this to something like Solana, and so Solana has this, like huge chain with a lot of apps with high throughput, but it makes some certain trade-offs and compromises. And so how do you reconcile a Solana-like approach with the Ethereum roll-up centric approach, right? Like, I mean, how can we get to a more seamless user experience in the Ethereum centric roll-up future world, but still retain, like what the user experience of transacting on a single chain has, right? Like, and so those are some of the challenges that we face when we kind of move into this more roll-up centric future world. And there, like focusing on interoperability, not in a very narrow bridging sense only, but as Casper pointed out, right? Like it has to be much more subtle than that, right? Like, and because we have validity proofs in the picture, which can be used for composing, for like message passing and so on, it is possible to construct mechanisms that abstract a lot of this multi-roll-up, multi-chain sort of architecture, and if we can abstract away this from users. So that's the kind of interoperability framework that we think will work. And of course, there's a lot of effort in terms of reconciling this multi-roll-up future on top of Ethereum. But we are very confident that with the right set of trade-offs, we should be able to reach those kind of interactions and experience pretty soon.
Yeah. So personally, I think definitely there's a lot of like Lego mixing possible with modularity, but Starknet I think is kind of unique in this sense. There's an anchor, if you will, within this ecosystem where this crown jewel, best of class Stark proving stack that Starkware is been building and also using in production. First starting with StarkX throughout the years. I think that's something unique and really something that ties together the ecosystem. So in that sense, I think also that makes Starknet somewhat the best ecosystem to be building these application chains. There's this key technical connector that makes it not just Legos, but also very secure with cryptography. And so theoretically you can move applications chains around, maybe even L2's around, but I think Starknet's has some extremely unique crown jewel properties that make this the best place to do application chains on.
I was wondering while you were speaking, and maybe Casper, you know better because I'm not an expert of SHARP, of the shared proving system of Starkware. But isn't it like if you use SHARP, all the application, even if there are different applications or even different L3s, if they all use SHARP, they don't really need to make storage proofs because they can like sort of automatically benefit from the data from another and still can be proven without any extra work. Is it correct to say so?
So the applications that are like, you can utilize the SHARP or you can utilize alternate provers as well. It's just about where you actually do the verification. And that's kind of like where the Cairo verifier comes into play, where we can deploy it on Starknet and give the applications developers the choice as to what they utilize for verification proofs. Yeah. And this will, I think, only be, expanded in the future as there's a variety of other provers and the ones that are being developed by Lambda class and so on.
My question maybe was more like, say you have two L3s or two applications that use SHARP as the shared prover. They use the same prover at the end. They send the program to the same prover that will batch all the transactions from all the chains and do the recursion and whatever. This is the same proving system. For these two chains, do they need like to build a storage proof system, or is it like natively possible to use the data from one chain in another because at the end they use the same prover in the same system?
No. So in order to be able to access data on another chain, you need to be able to relay some sort of commitment, such as a block hash from, let's say, an L2 to an L3. And that would be made possible by integrating with, for example, sequencers such as Madara. If Madara was able to it would greatly improve the UX of being able to then verify a storage proof against that block hash, that initial commitment, or like a root of an accumulator. But the SHARP is not a constraint.
Yeah. So I think there are two things to take care here, right? Like, so there is one is the validity proof of the execution, and second is basically the fork choice rule that like the specific roll up or chain follows, right? Like, so you need to have like a proof of execution and a proof of like you need to prove the correctness of the fork that you are on, right? Like, so ordering is also very important. Like for example, Herodotus, like works on the block hash, for example, which is the finalized block hash, for example. So the validity proof is not sufficient enough, but the beauty is that you can use different sorts of proving systems to kind of compose these things together. So right now, like for example, the Cairo verifier on Starknet is the first step. I'm pretty sure you guys will have plans to do verify this on other chains as well, for example, and so on. And so a combination of this will be able to kind of reconcile these fragmented like ecosystems a little bit. That is what my thinking is.
Because I don't know, but I understood, but I read a bit fast the article about the aggregation layer of Polygon, that they were saying that with proving all kind of blockchain that would commit to the layer, they would sort of be able to access the data of the others quite easily, and without, I think, deploying a whole system of storage proofs. That's why I was asking if it was meaning that having one shared prover, not Sharp itself, but a shared proving system for one single ecosystem of blockchain would mean that all these layers would actually not be fragmented in terms of data, and if it would mean in the end that actually would not have neither app chain nor L2 or whatever you want, but sort of cluster of blockchain commit using the same prover at the end.
So,
I think, sorry, you want
yeah. Just real quickly, but you do have to consider one thing is prover interoperability means like the format that you're kind of producing these proofs, that's interoperable. But you do also want to be mindful that there's things you put into it, which is what you are proving. So if the protocol of the chain itself, that agreement itself is different, then it's not enough to just have a shared prover.
Yeah, it's not about having a shared prover actually. It's basically, in general, can we take these proofs together and have circuits or programs in general that can verify different sorts of proofs. So if you want to kind of, let's say, do an aggregation between, let's say, a ZK sync proof and a Cairo proof, for example, and if there is an intermediate program that can verify proofs from both systems, and of course also verify the ordering, that should be enough to have trust, minimize message passing between these protocols. So you don't really need to have a common prover for all these systems. We just need to, I've seen a project that is written in Cairo, which verifies a Maiden proof, for example. So which means that you can write a program in Maiden, which can then be verified in a Cairo program. And so any state in the Maiden program can then be read in the Cairo VM trust minimized way. And of course, Herodotus is doing a lot more work on that in general. But that's the general.
I've got to pull us back in because we're running out of time. I think proof aggregation is really important to be able to have composable proof systems, incredibly valuable. To sort of close us out here, quickly, hot fire question: what makes AppChain successful in the long term?
My bet would be client-side proving. State channel applications, I don't think those have been exported significantly yet, especially on like L3's. And got a shill, so Herodotus Turbo, so essentially being able to make those cross-chain queries in one line of code.
I think app-specific rollup tooling needs to mature more, in the sense that right now the cost of bootstrapping a app-specific rollup is even today still large. It's of course much better than spinning up a new separate chain in itself. But we need to make the app-specific rollup stacks so mature to the point that today when a lot of developers think about writing apps, they first develop a smart contract or write a Cairo program, for example. And I would like the app-specific rollup stack to move to a point where it's just so easy and lightweight to deploy it that, most apps will just run on an app-specific rollup that will be deployed by, any sort of RAS player, for example, and so on. In general, I think we should be moving to a more asynchronous blockchain services sort of a world where there are large microservices and there are smaller microservices and there is some sort of trust minimized message passing between each of them.
Yeah, so in terms of what makes AppChain successful, I think in one sentence would be users, just serving users better in different domains, yeah.
Well, I think that if we want app chains to be successful, we probably need to really solve the fragmentation of the data, being either with shared proof or shared something or whatever the system will be the best. But to me, yeah, this is really the need for the app chain to be successful.
All right, fantastic. Brilliant panel, guys. Many thanks for being here. I hope you've all had a fantastic day. Enjoy the rest of the evening. And if you have any questions about app chains, L3's, feel free to talk to myself and the panel members. We'll see you all very soon. Take care.
Thank you.
Thank you.